Hello.
Shivaji, can you hear me?
Yeah,
Okay. How are you?
I'm fine. And you?
I'm fine. Thank you. Okay. So I've shared a file with you where we have got two questions. Should we try those?
Yeah.
Okay. Give my pointer.
Yeah.
Okay. We have got, I think we have got at least 15 questions. So let us see. Let's start with the first one. Right, Shivaji?
Mm-hmm.
Okay. So first question we have is, uh, wait, give me a second. Okay, what is this element symbol in the box in the upper right corner? Okay, what I'll do is, I will get, okay, very good. Yeah, yes, okay. Wait a second, actually. Okay, so you want to say this is helium. Let's do the second one. We give the answers here also, so that we can check it after we are done. Helium. Okay, what about the second one? Given in the list of the numbers in the upper right corner tells you that there are 7 electrons. Where in the atom? Like if it is given like this, 2, 7. What does
valence electron.
Okay, okay, fine. Valence electron. Okay. This is the average atomic mass of fluorine. Okay, this may not be knowing. See, its atomic number is 9. So, its atomic number is 9. It means number of protons are 9, right?
18.
Yes, very good. That's right. 18 point something it is. So, proton is 9. So, it means electrons will also be 9. Isn't it? If electrons and protons are 9, then we can find the atomic mass. That will be your neutron. So because neutron and proton makes atomic mass, right? So your answer is correct. The numbers on the right side of the box represents the arrangement of element. Okay. Arrangement of what? What we see, like what are arranged? If in the periodic table you have to see the elements, then what is actually being arranged after looking at their atomic number? Sorry, I didn't get you. Okay. It can be electrons, right? Because we are arranging electrons. This question is little tricky, and you have to read it again, right? Okay. How many protons does fluorine have in its nucleus? Okay, this is easy. So you want to say 9? I will write it here. 9. Fine. How many neutrons?
9.
9. Okay. On the periodic table, the halogens are in what column?
The last one.
Yeah. So what is the name of the column? This is 17, or you can say 7. right? You count the columns, the periodic table goes like this. I will share periodic table with you. So that will make our questions easy. Give me a second, please. Okay. Okay, here we are. This is 17. And this is halogen group, right? So, which column? If you have to name the column, then you will you can say 17. Right, Shivaji? Okay. Right. Let us go to our next question. One is called 1.
I don't know.
Okay. There's it starts with A. Okay, I'll tell you. See, this is alkali group. These are alkali groups, right? They have the tendency of giving one electron, and the group 2 is called alkaline metals. Alkali metals and alkaline metals, we have we have these names, and actually these all are called representative elements. Right? Why we call the column 1 have all the alkali metals? Because they form strong alkalis with water. So when we will do chemical properties, we will do it today. Then I'll show you how they form alkalis with water. And group 2 is called alkaline metals, alkaline earth metals. They form weaker alkalis. They are most found, inside the crust of the earth. So thus they have this name. Okay. So now we have got the next question. Column 3 through 12 are called as
transition metals.
okay, very good. That's right. So transition. One is in column 14. This column is called dash. Okay. First, let us find out where is silicon. Here it is. Right? And what do we call this group, this column? We call it carbon. Carbon. They are carbon group, or you can say carbon family. Right? Which group it is? To tell me the group, then what you will say? Like this is group 1, this is group 2, this is group 3, 4, 5, 6, 7, 8. Right? These are group B. The elements, transition elements, they are actually group B. So total we have 18 columns. So 14, silicon is in 14th column, and we call it which group? 4th, right? Group 4. 8. Okay, so let us go to our next question. How many electrons are there in the outer energy level of calcium? Would you see the periodic table? Is atomic number 20, right?
4.
So if you read the electronic configuration in
C882.
okay, you want to say 2?
No, I want to say, yeah, 2.
Okay.
In the valency electron.
That's correct. Very good. That's the right answer. Rows of periodic tables are called, what do we call rows? Call them groups or periods. These rows, you see, these are rows and these
period.
are columns. Periods, very good. Okay, so we call them periods. Are known as groups. This you know. So, see, when we try a few questions, that makes our concept more strong. A kind of practice, right? Okay. You move up to the right from the step line towards fluorine. The reactivity of the element does this. See, I told you, Shivaji, I told you that metals are very reactive, right? And as we go to this side, that is from left to right, the reactivity decreases. And these non-metals, these are all non-metals, have got reactivity as compared to these metals. Metals gives up electron, non-metals takes an electron. Right? So what will be the answer for this one? Going towards fluorine. Reactivity of the element will, fluorine is here, right over here.
So 1.
Okay, so the reactivity will be what? I mean, it is 287. So what say? It is need of electrons, or is it it will give electron, or what do you get from this? This is fluorine. Okay, I'll help you. As you move up to the right from the step line towards the fluorine, the reactivity of the element, see, this is the most electronegative element, fluorine. Why? Because they have got the tendency of taking one electron, and one electron can make them stable. Their orbit will be completely filled, right? So we can say it increases. Any one element smaller than 93 that is not found on Earth. This you may not be able to do. I'll tell you. Actually, this is atomic number 93. That is not found on Earth. If you see here, as you come to these blocks, we find this element which is having 43 atomic number. Right? So 43 is for write the configuration where it will go. Yeah. 43. Like if you have to write the atomic number of the elements, then what will be the 43? Where it will be placed? Like block, B block. Try. We are just B block. It is actually the element is it starts with T.
Oh.
And this is technetium, TECH, right? And that's right. You're very correct. This is technetium, and it is here, right over here. This is the D block element. Okay, great. The halogen means these are the group 7 elements. So what does it mean? Halogen. These actually halo is the word for salt. So these are salt forming elements. Remember, when we will talk about the reactivity, you will find that they have got the tendency like chlorine, fluorine, iodine, they're all in group 7. You see here, these are all halogen here to here, and they form salts. Salts means if any action occurs, then there is something left in the form of salt. Okay, the most metallic element in row 2. Let's see. Where row 2? This row 2, right? Reactive element will be a most metallic element. I mean, which shows metallic property, and you know metallic property decreases from left to right. So the question is most metallic element. Okay, which this is because metal starts from left to right, you get non-metals. These are all metals. These are all metals. These are metals. Now we're coming to this side. These are all non-metals. Metals gives electron. Non-metals gains electron. You can say lose electron, lose their electrons, and non-metals they gain electron. So as you move from left, this is left side of the periodic table, this is right side of the periodic table, right? So as you are moving from this side to this, the metallic character decreases. Okay? I will be going through this, and then here I have got a chart which will be very helpful to you. Let me show you. If you go through, you will think that it will concept easy. That from this side to side we have got. Just a minute, Shivaji. Page 2. Oh, here it is. Do you have a pointer? You have to scroll down. I'm on page 2.
Yeah, okay, I see it now.
Okay. So here, this is metallic character. We are going towards non-metallic character. And if you move from right side to left side in the periodic table, you are coming towards metals. So means metals are here, and if we are moving to this side, the non-metallic character increases. And we had a talk about atomic radius, right? And ionization energy also I told you. So 2 things we have done, and metallic character we did before this when I told you that these are all metals, and as we move to this side, non-metallic character increases. These p elements are actually non-metals and metalloids, right? Here, these are metalloids. 7 metalloids are there, and these are all non-metals. Right? So this will help you. This chart is really good to know what is going as we go down, what happens to atomic radius. As we move across the period from left to right, you see ionization and energy increases, and electron affinity. I'll tell you what is that. Let us finish this. This is the most metallic element in row 2. Now you like to try most metallic, like metal starts from here and it goes here. So it means most metallic will be lithium, because it is in row 2.
Yeah.
Right? Okay. So these were these questions, and okay, I think we have few more questions. Let us see. Name a metalloid in row 2. That is easy. A metalloid in row 2. These are all metalloids.
Yeah.
These are metalloids. Where is row 2? This is row 2.
So, carbon.
Okay, see, metalloids we have. Metalloids. Boron, right? Boron. Is your, but only this much are metalloids. 7. These are metalloids. These are all metals, and there is a zigzag line, this one, and then we have 7 metals, and 5, these are all non-metals after that. So actually the metalloids are in the center between non-metals and metals, or you can say metalloid is the layer which separates metals